Hello students, in this class we will discuss about the next converter is the DC to DC boost converter. So this DC to DC boost converter, another name is step up chopper. Another name is step up chopper. So this boost converter is which converts fixed DC to high value of desired DC. That means we have some DC value, for example 10 volts. It can increase up to 12 volts to more than 12 volts. It may be 14 volts or it may be 16 volts. That's why which converts fixed DC to the high value of desired DC voltage. DC or DC voltage, anything, better to take it as voltage, right? Which converts fixed DC voltage to high value of desired DC voltage. The another name is DC to DC boost converter. That means DC voltage to DC voltage boost means increases. The output voltage will be more than the input voltage. The output voltage value high compared with the input voltage. Here the circuit diagram of this DC to DC boost converter same as the buck converter, but there is a small changes. That is, the source voltage is connected to the inductor and switch is connected across the source voltage, and the switch point is connected to diode, and the capacitor is connected across the load. Okay, here source connected to, which shows in the diagram, source connected to inductor and switch and diode parallelly connected. Both are switch and diode parallelly connected. The application of switch and the application of diode we already discussed in the buck converters. Parallelly connected, and end of the diode will be connected to parallel connection of the capacitor and load. Load is nothing but we will get the output voltage. Load voltage is nothing but simply we will get our required output voltage. Then we will discuss two modes of operation. First, a simple thing, we will giving the input here and we will get the output here. So in this boost converter, the given input value will be less than the output value. In order to increase the voltage, we are using this boost converters. So what is the work of the inductor here? Inductor application doesn't allows sudden change in source current. What is the another meaning? The another meaning is maintain constant source current. Maintain constant IS. That means maintains the constant source current. Okay. Switch, you know that diode we know that, and capacitor is which allows the harmonics. Harmonics will be eliminated by this capacitor. That's why the construction is like this. And the mode 1 operation. So mode 1 operation means in the mode 1 operation is nothing but switch is off, switch is on, and diode is off. Look at here, the switch is on here. We are on the switch by giving the pulse width modulation. In the switch we are using switch, in place of switch we are using MOSFET and IGBT. MOSFET and IGBT. Yes? Okay. Here switch is on and diode is off. Look at here. When the switch is on, diode will be open. Why it is open? It will be short circuited, and if you observe the source voltage, from the source voltage current will be flow first short circuit, because in order to avoid the diode have some cutting voltage. So due to the cutting voltage it doesn't enters the diode. That's why diode is off and switch is short circuited, automatically the current will flow. The remaining part will be isolated from the circuit. That's why whenever switch is on, diode is off, the current will flow from the inductor to again source. When switch is on, the diode is off. The source current IS will flow through the inductor and again enters into the source. Look at here, this will be isolated. From this we can write the equation. From this is the source, that's why we will get plus and minus, and inductor will, whenever the inductor current flow through the inductor will get some potential drop. That potential drop is VL. So from this, apply KVL for this loop. Apply KVL for this loop. We will write the relation, that is minus Vs plus VL equal to 0. From this, Vs equal to VL. So just take it, Vs is nothing but the input. In order to understand the input, better to take. And this is the input. What is the voltage across inductor? Voltage across the L into DIL by dt. And we can make some points here, that is DIL, nothing but change in current. We can write the change in inductor current when switch is closed. That's why you can take it as the switch is closed, because we are considering when the switch is closed. What about dt? Change in time. Change in time means it is on time. On time can be write it as dt. Always on time is nothing but equal to duty ratio into total time. T is the time period. T is the total time period. That's why just write here again V input equal to L. DIL can be write it as change in load current when the switch is closed, and dt is in place of dt you can write duty ratio into total time. So from this we can write change in inductor current when the switch is closed. When the switch is closed, we can write like this: V input by inductor into d into t. This is the first equation. This is the first equation. The change in the inductor current will be equal to the change in the inductor current when the switch is closed equal to the V input by L into D into T. V input is input voltage, L is the inductor, D is the duty cycle, T is the time period. Here don't confuse, D is the duty cycle, T is the time period. This is the change in the inductor current when the switch is on. Next we will discuss the second mode. So in the second mode, switch is off is the second mode. What happened when the switch is off? This is an off position, then the current from the source will not be enter here. The current will be source is enter here, and it again avoid the cut-in voltage, because cut-in voltage value just 0.7 volts, source may be more than 0.7 always. That's why the current is flowing like this. So this diagram is modified like this, that is source voltage supply the source current through the inductor and switch will be off, diode is become short circuit, and in the capacitor this is the inductor voltage. So source current is nothing but this is the inductor current. What happened when the switch is off? Diode is on, D is on, that means diode is on. Now if you observe here, we can apply the KVL for this loop. The source voltage, capacitor and load are connected in parallel. That's why the voltage across capacitor and voltage across load both are same. So we can apply the KVL here. By applying the KVL, again you can take it as source voltage is nothing but the input voltage. Both are same. So by KVL, here input voltage is always plus and minus, inductor voltage is plus and minus, and the load voltage is plus and minus. By applying KVL, minus V input plus voltage across inductor plus output voltage will be equal to the 0. Then we can write voltage across inductor equal to V input voltage minus V naught. From this we can write what is inductor voltage? Inductor voltage equal to inductance into DIL by dt. Inductance into DIL by dt. What is L here? L is here. DIL means change in inductor current when the switch is open. What is dt? Off period. We can write it as the off period. Okay. From this VL can be write it as L into change in inductor current when switch is open. Off period can be write like this: 1 minus dt. We can write it as the 1 minus dt. So replace this inductor voltage by this by this thing. So replacing this, we will get L into change in inductor current when the switch is open by 1 minus dt equals to V input minus V output. From this, we can directly write the change in inductor current when the switch is open equals to input voltage minus output voltage by L into 1 minus d into t. Just take it, this is the second equation. Just take it, it is the second equation. When the switch is open, this is the second equation. Okay. So most important thing, what is the relation between on time period and off time period? Don't confuse here. I will give some clarification here. Generally, total time period, the switch on time period is like this. Total time period equal to on period plus off period. Generally, the relation between the duty cycle and this is T on by T generally. Okay, T on by T. T off equal to T off equal, so T on by T. So in order to get the T on, just directly total time period into dt. That's why I am replacing on time period with dt. And what is half period? How we will get the half period? The half period equal to, so in place of d, T on can we write it as T minus, so here d is there, d equals to T on by T, you know that. What is the relation between a T on and T? I can write like this, T on equal to 1 T minus T off by T. That's why here D equal to 1 minus T off by T. From this I can write T off by T equals to what happened, 1 minus T. From this I can write T off equal to 1 minus D into T. That's why I am replacing like this. First equation for the on time and the second equation for the half time. Okay, that's why I am replacing like this. So we find out inductor current when switch is open, and we find out inductor current when switch is on. But the property of the inductor, for inductor, net charge for full cycle is 0. Full cycle is 0. That's why the current 1 plus 2 will be equals to 0. So 1 is, what is 1? Change in inductor current for closed switch plus change in inductor current for open switch equals to 0. So change inductor current, closed switch value, V input by L into dt plus dt plus V input minus V naught by L into 1 minus d into t equals to 0. So by simplifying this, we will get the relation between V input and V output like this. Just do the simplification in your notes, that will be useful in your exam. So I am directly writing because it will take more time. So I am directly writing the relation between V naught equal to Vi by 1 minus D. Output voltage equal to input voltage by 1 minus D. Okay, this is the relation between the input and output voltage. This is the relation between the input and output voltage for the step up chopper. For step up chopper. For the step up chopper. Okay. So if you observe here, if we have some disadvantage here, that is, if duty ratio equal to 1, what happened? V naught equal Vi by 1 minus 1. Vi by 0 become infinite. It is unstable. It is unstable. It is not a stable, it is a unstable. That's why always D value must be less than 0.7. Must be equal to, is less than or equal to 0.7. D value preferable. If D value is greater than 0.7, it will lead to instability. It will lead to instability. It will become the unstable. System is not working properly. Not working properly. Yes. So this is about the step up chopper. For the step down chopper, output voltage equal input voltage into duty ratio. For step up chopper, output voltage equal input voltage by 1 minus D. And the most important thing, D is not preferable. D is not preferable for 0.7. Okay, right. These are the waveforms related to the boost converter. So in this waveforms we have pulse, the switch time will be explained in this pulse. This on means the switch will be on for this particular pulse. Off means switch will be off at this time. And this is the time period. This is repeated per every cycle. So the same time period will be repeated like this. So it consisting of the same time period. In the time period, some period is switching on time period, some period is half time period. In that period, when the mode 1 operation means switch is on. In that operation, look at here. In that operation, what happened? First we will look into the inductor voltage. In the inductor voltage on time, what happened? In the mode 1 operation, when the switch is on, the current will be flowing like this. The total source voltage will be equal to the inductor voltage. That's why for on time, inductor voltage is constant, that is the source voltage. Yes, source voltage. What about off time? In off time, look at the off time. This is the mode 2 operation. Whenever inductor is off, in the off time, inductor will change its polarity, and addition with the source voltage, inductor will supply the voltage to the load. That's why inductor voltage will be become is negative. This is the negative side, and this will be repeated for on time again positive voltage, on time negative, off time negative voltage. This will be repeated. This is the inductor voltage. What about inductor current? If you look at the inductor current, in the on time the inductor current will be increases to maximum value. Whenever it is off, it is decreases to minimum value, and it will be fluctuate between I1 and I2 current. I1 current is the current which is in on state. I2 current is the current which is at off state starting. So this cycle will be repeated. This cycle will be repeated like this. So we are designing the inductor to maintain the continuous current. We are selecting or designing the inductor current. Inductor is designed to maintain continuous current. Otherwise, current will be discontinuous. Continuous current. Otherwise, current will be discontinuous. That's why we have to give the continuous current. What about voltage or source voltage? In the on time, look at here, the source voltage is generally we are taking middle of the cycles. So in that source voltage we have some positive voltage here, but when the on time the switching will be decreases. There is no source, that's why the source voltage is try to decrease. That's why the source voltage is try to decrease. And whenever the off time, the supply will be added for the circuit. So by combining the inductor voltage and supply voltage, the voltage value will be increases. So in this manner. Again it will be repeated. For on time it will be decreases, for off time it will be increases. Like that. This is the output voltage or capacitor voltage. Both are same because connected parallelly. Voltage across capacitor and voltage load or output, both voltages are same because both are connected in parallel. By this we will get the voltage. And the output current, here output current simply follows the output voltage or capacitor voltage. In this output current, in the on state, the output current is slightly decreases. It is slightly decreases, but in the off state slightly increases because supply will be added here. If there is no supply will be added here. These are the waveforms related to the boost converter. Okay, this is about the boost converter waveforms. First look at the boost converter and mode 1 operation when the switch will be on, and second mode 2 operation when the switch will be off, and the relation between the input voltage and output voltage and the waveforms. A problem related to the boost converter is given here. So first, the input voltage of boost converter is 100 volt. First write down the given data. So he given the input voltage. The input voltage equal to V input voltage equal to 100 hours. The on time period is 40 millisecond. So he mentioned on time period, that is 40 millisecond, and 100 millisecond time period. So he given total time period also, that is 100 millisecond. And the question is determine the output voltage. He mentioned it is a boost converter, that's why the boost converter, the relation between input and output is like this. The output voltage equal to input voltage by 1 minus duty cycle. So first in this we have to find out the D, duty cycle. D equal T on by total time period. So T already given 40 millisecond. By total millisecond, his total time period is 100 millisecond. Just remove here. We will get the 0.4. D value is the 0.4. Now the relation between input and output would equal to V naught equal to V input equal 100 by 1 minus 0.4. So from this 100 by 0.6. So by doing the calculation we will get 166.66 volts. Therefore the output voltage equal to 166.66 volts. So the input voltage is 100 volts only, the output voltage is 160 voltage. So if you observe here, output voltage is more than the input voltage. That's why it is called the boost converter. That's why it is called the boost converter.